Hi, I'm Nathan Crone with Triton Systems. With decades of combined experience in subsea tooling, autonomous software development, mooring analyses, and vessel operations, our team has developed a revolutionary vessel anchoring system to enable truly autonomous vessel operations. We call it Smart Anchor. Since the 90s, Triton Systems has been pushing the envelope on what is possible through focused engineering and technology development. We turn ideas into concepts, make them practical, and then flush them through engineering, analysis, and testing to ultimately drive them to market. With over 40 patents, our team of 120 engineers and scientists develop these products out of the heartland of innovation, Massachusetts. We have the knowledge and capacity to deliver state-of-the-art solutions to the military and commercial sectors. In addition to our work in defense and homeland security, we also operate in the medical and human health space, as well as energy and environment. In just the last 15 years, we've created over $4 billion in shareholder value through successful spin-offs of companies that are delivering these solutions. The challenge in front of us today is one that affects the global naval fleet and the need for unmanned vessels navigating high-risk waters on the front lines. At the direction of the Navy, our primary objective is to develop an automated anchoring system for use on board these vessels. Current naval anchoring evolutions are antiquated and require multiple human users to both determine an anchorage location and physically operate equipment to execute the anchor's deployment and recovery. Under PMS 406, with target platforms such as medium and large unmanned surface vehicles, or USVs, human users are not an option. Focusing on the details, our solution's fundamental requirements are the following. 1. Autonomously determine an anchorage location and calculate a swing circle, line payout, and vessel maneuvers to set an anchor. 2. Deploy anchor and chain, while assessing for anchor drag. 3. Maintain watch over the anchorage, and automatically adjust payout in response to weather and vessel traffic. And 4. Recover or slip the anchor in an emergency. Setting the bar, right now, current anchoring evolutions are too manpower intensive. At minimum, for commercial applications, crew requirements often involve 1 officer to plan anchorage, 3 able-bodied seamen to operate the anchor handling machinery, 1 officer to maneuver vessel, and 1 officer to stand watch. Military applications often call for many additional personnel to ensure there are no gaps in command and execution. By simplifying the mechanics and optimizing the decision-making around anchoring best practices and field fundamentals, Triton's autonomous anchoring system can streamline routine anchoring operations for all unmanned and manned vessels with repeatable logic-based actions. For rapid response, Smart Anchor is the optimal technology to enable an unmanned vessel to passively station keep, long-term, near the target deployment area. This simplified system is applicable outside the unmanned space to manned military, commercial, and recreational or private vessels. In more detail, Triton's Smart Anchor system enables autonomous vessels to operate truly autonomous. Our system utilizes electronic chart data and live field situational awareness to determine the optimal location to anchor the host vessel. Dependent on the vessel's mission, the system will scout the surroundings for a location that meets set preferences predetermined by the vessel operator. These parameters can include minimum or maximum water depths, proximity to known subsea hazards like buried cables or pipelines, or distance from other anchored vessels. When the weather changes, Smart Anchor accounts for any increase in tension on the mooring line and pays out additional chain to maintain anchorage. This adjustment to configuration recalculates the swing circle and distances to other assets. If this location is then deemed compromised, Smart Anchor will reassess the surroundings for another anchorage location and instruct the vessel to move if necessary. As illustrated in the figure, Smart Anchor's suite of sensors in combination with the vessel's systems monitor the live vessel traffic through AIS and radar. The system supports the vessel's ability to maintain watch in alignment with regulations and best practices. To ensure Smart Anchor can be implemented on any vessel, Triton is working with the American Bureau of Shipping. ABS is reviewing the Smart Anchor mechanics, decision-making process, and architecture as part of its new technology qualification process. During the Phase 1 period of this program, Triton received a feasibility statement of maturity from ABS of its decision tree command hierarchy and its automated windlass system concept. Now, in the first year of the Phase 2 period, Triton is working through ABS's concept validation stage. Building off the successes of Phase 1, Triton has worked with Appleton Marine to further refine the windlass mechanics, and is also building and testing its anchor controller software that will be used to communicate with the host vessel's autonomy bus and control the anchor handling machinery. To date, on-water integration testing has been performed with our partners at MIT to demonstrate Smart Anchor's ability to work with a third party's host vessel architecture. By the end of the Phase 2 Year 1, we expect to achieve a TRL3. Next year in Phase 2, Option 1, Triton aims to increase the TRL to 4 through prototype mechanical testing, on-water anchor controller testing, and simulated anchoring evolution demonstrations. Year 3 in Phase 2. Option 2, Triton is set to achieve a TRL5 through on-water prototype mechanical and software demonstration. To achieve a TRL7, Triton is looking for follow-on funding to conduct a demonstration of full-scale mechanics and the Smart Anchor software suite on a full-scale vessel of opportunity. I'm excited to highlight these 5 key features that will help disrupt the current trend of marine operations. Each of these features provides significant advantages over the state-of-the-art and benefits to the maritime industry. Specifically, 1. Automated windlass equipment provides a vessel the ability to streamline anchor deployments and recovery without the need for manual human intervention. 2. A modular system implementation approach enables vessels to customize and scale exact features needed of the Smart Anchor system. This optimizes costs and eases risk and complexity of integration. 3. Smart Anchor's autonomous decision-making ability removes the risk of human error and variability and enables routine, predictable anchorage selection and mooring arrangement based on industry and vessel best practices. 4. A platform-agnostic autonomy architecture allows Smart Anchor the ability to integrate with any host vessel's architecture, which alleviates the burden of having to modify a vessel's autonomy bus. 5. Real-time monitoring of the dynamic field, vessel position, and even weather enables the vessel to securely station keep near the area of interest. Throughout this SBIR Phase 2 program, Triton will be able to advance Smart Anchor's TRL, though concept and prototype validation, by way of in-house software development, benchtop testing, third-party architecture integration, on-water behavior testing, and finally a prototype function and behavior demonstration. After these demonstrations, follow-on funding and support will be needed to prove the mechanical and autonomous system's operability on a full-scale demonstration vessel. Unique to the Smart Anchor system is the ability for components and features of it to be used without the need of the other. Shown in this table are primary components and packages that make the Smart Anchor system the innovation that the marine industry needs. Depending on the transition vessel or the market need, the Smart Anchor system can be had in either mechanical or software-centered levels. If looking to simplify manned vessel anchoring operation, with the need to manual deploy and recover an anchor, the automated equipment controlled by the Smart Anchor function-only software can be used. A chain cutter can be supplied with or without the rest of the system, also controlled by the Smart Anchor function-only software. For manual equipment where the risk of human error needs mitigated, the Smart Anchor software suite can instruct the vessel master on where and how to anchor. Then there are 3 levels of complete packages. Smart Anchor Level 1 includes the automated equipment and the suite of software to determine where and how to anchor. Smart Anchor Level 2 includes Level 1 features and also monitors the live field traffic and weather to provide real-time alerts and recommendations to the operator. Finally, Smart Anchor Level 3 includes all mechanics and the entire software and integration suite to enable truly autonomous anchoring evolutions. This system coordinates with the vessel's autonomy bus to make decisions and execute anchoring operations. Our team at Triton Systems is seeking a partner that wants to make unmanned vessels truly autonomous with self-anchoring capabilities. By using Triton's Smart Anchor system, an unmanned vessel is transformed into a fully autonomous vessel capable of maintaining position near its mission deployment zone. These moored vessels would stand by ready for rapid and immediate engagement and mobilization. So far, our team is working closely with NAVSEA and PMS 406 to advance this technology and demonstrate its capability on a full-scale vessel. We've also received community support and interest from the military, commercial, and private sectors. With the ability to respond to outside factors such as weather severity changes, anchor dragging, or imminent collision threats, Smart Anchor truly enables the potential of unmanned vessel fleets. Please reach out for any inquiries on how to anchor your fleet the smart way.